Recording in progress.
It's not square bracket because here we're looking for smaller, so we don't want the equal part for it.
Sorry, was I meant to raise my hand?
Yeah, go ahead.
Just like to ask, is it possible to like, what happens if you do it on the other side? So instead of like, instead of saying x minus 1 over 2 minus x, what if you do like 1 over 2 minus x minus x?
You would get the same result there. It doesn't matter which way you do it. I can do that one if you want. So it would just, the only difference would be, so here you have 1 over 2 minus x. You just don't have the negative sign, so you would still get the same answer. It doesn't really matter.
All right, thank you.
The reason that we can't factor numerator and cancel because you're canceling one of your, and wait, you can't actually cancel because you have x minus 1 squared and x minus 2. You can't cancel out anything. But even if you could, you wouldn't, and you can do it, but just remember to have your domain before it. So you remember that that's like something that makes your denominator 0. The set isn't empty because these two cases are different from each other. So you basically, it's not the intersection of those two cases, it's the union of them. Can you see? Okay. Yes, we're gonna post the solutions. Okay, so for this question, the first step, you want to make it as simplified as you can. So first step, you can multiply by -1. And so this will change the direction of your inequality. So you have 6, 3x squared divided by 2 greater than 4. Then for your next step, you want to make your x squared like be by itself. So you'll multiply it by 2 over 3. Then here you have 4 greater than or equal to 0. X squared 8 over 3. Now for these ones, you want to like separate the cases. So you have x squared smaller than or equal to 4, and then x squared greater than 8 over 3. For this one, so you have x is between -2 and 2. And then for this one, you have x smaller than negative square root of 8 over 3 union x greater than square root of 8 over 3. So basically, so then you have your x is from, so here you have from -2 to minus square root of 8 over 3 union, here you have square root of 8 over 3 and 2. Does anyone have questions about this? And so the question asks you, what's the greatest lower bound? So here you can see the biggest lower bound you can pick is -2 here. So your lower bound is just -2. Yeah, for here, it's the greatest lower bound you can pick. I think if the interval was open, since -2 isn't there, you can't pick the greatest lower bound. Okay, so for this one, remember that there is this formula. I'm gonna prove like how you get it. So if you had f prime of, well, you know that f prime of f of x is equal to f of f prime of x, which is equal to x, right? Here, if you can take the derivative from both sides. So here you would have 1. So you have 1 equals d of x of f inverse of x. And then so you have 1 is equal. So you want to take the derivative of this, you can use chain rules. So you have f prime of f inverse of x times f inverse at x, right? And then so you can see that here, basically this looks like what we want from the question, right? So this way you have so this way it would make it easier because now we only have to find the derivative of your f prime. So you don't really have to go find the inverse, take the derivative of that because that takes like really long. And so here we have x is x to the power. So f prime of x is going to be 5x. And then so here we want prime f inverse 6, right? So basically comparing with this, you want to find the x that you have here, right? So you would just make, so you have I'm just going to put alpha. And then, so from this, you know that f of alpha is equal to 6. So 6. Now, if you solve this, you're going to get alpha equals 1. So now we can use that. So you want f prime. Here we said alpha is 1, right? So and then now we just substitute 1 to the f prime we found here, which is going to give us 5. Now remember here, this is the final thing we wanted. So we have f inverse prime of x is equal to 1 over. Usually with polynomials that are degree more than 3, you can guess, for example, 1 minus 1, 2 minus 2. Usually the ones that they give on the exam has one of these on the as the roots.
I have a question.
Yeah, go
Why?
ahead.
So why f of derivative of f of x is equal to f the inverse f?
Do you mean this part?
No, I mean for the very first that you wrote the f of prime of f of x equal, yeah, that one.
Oh, that's just the way that it works, because if you think about it, so you know that your f prime of x equals y, then f of y is equal to x, right? And then basically using that, so if you have like f, so basically since here you have f inverse of x, right? So assuming this is equal to y, you basically take f of y, you're gonna get your x.
Okay, thank you.
Go ahead, Joseph.
I'd just like to ask, so if you're ever trying to find the inverse, will you have to prove that it's for 1-to-1 first before you do it, or can you just assume in this situation?
This part?
Yeah, like when you're getting the inverse, or like if you say you do it the longer way, basically, and you want to get the inverse first, will that for getting the inverse, will it be what am I trying to say? Will you have to prove that's the function is 1-to-1 first before you take the inverse, or no?
Oh, so you're saying like if you don't go by this way and you just from the start take the inverse?
Yeah. Will you have to prove it first that it's 1-to-1 or no?
No, I don't think so, because it's a polynomial. But the thing is, here you have x5. How would you find the inverse?
No, it's not. I'm just asking, like, will you have to, if you are trying to find the inverse of that, though, will you have to prove the function to be 1-to-1?
No, but the thing is, so for polynomials, if you have a degree that's even, right, it's not 1-to-1, right? So basically, they have to give you a domain that you can use it. If they don't give you a domain, then you're going to get two inverses for it, because it's not 1-to-1. But if it is, you can just explain why it's 1-to-1 and then use it.
All right, thank you.
I just guessed it and one worked for it. Usually when the degree is high, you can just guess 1 minus 1, 2 minus 2. And it's usually, if they give it on the exam, it's like, I just took the derivative from both sides for this part. But we also had it as a formula. You haven't learned this part? Okay, then. But It's not a rule. You can take the derivative from both sides. But if you haven't learned this, then I guess you don't have it. That's okay. Wait, actually, that's supposed to be F inverse. Yeah, but if you've learned this part, then the next part is just taking the derivative from both sides. So you don't actually need a rule for it. You can just use the chain rule. haven't started explaining. Okay, so for this one, when it says that we want f of x to be differentiable, first it has to be continuous, then your left and right limit, derivative should be equal. So first you want for it to be continuous, you want, so limit of f of x, x goes to f of 0. And so the greater part, since you have equal part, this part is already, this part is already true. And then now you can check the other parts. So limit of f of x. This one is the second formula. This one. So you have p0 minus 1 squared, which is just. And then the second one is limit of f of x. So you have e to the power of 0 plus, that's just going to be 0. So you have 1. Now you want these two to be equal. So you have b equals 1. And so now your next part is to find the derivative. So you want f prime 0 to equal to left side of 0. So, this one's the second equation here. So you have, this is going to be 2b x minus 1. But we have 0, so this is just 2b, and here we found that b is 1, so just 2. Then here we have 0. You have each, so you want to take the derivative of each. E to the power of x is just e to the power of x, plus this one's just 8. And then so 1 plus a has to be equal to what you have here, so 2. So here, wait, actually, this one should have a minus 2b plus minus 2. So you have minus 2 equals 1 plus a, then your a is going to equal to minus 3. Does anyone have questions about this one?
Can I see the question of question 4?
No, I'm just waiting like for a few seconds to look at the question and then I'll explain. Okay, so for this one, you want the equation of the normal line. So you have y equals f of x 0 plus minus 1 over. Okay, so this is basically the only difference from a like the equation of lines we have is that here, since you want the normal one, you do 1 minus the slope, which is just derivative at that point. Okay, so here consider that you have you want to take the derivative of this first. So this part is going to be by the product rule and then change. So first you have 2x y cubed plus 3y squared x squared. Now the reason that we still have the y prime is that we have like dy dx here, and that's not equal to 1, so you need to have the y prime. So it tells us that we will have 1 minus 1, so now we can substitute here. So here you have minus 2 . The reason I said equal to 0 because see here we have equal to 0, so when you take the derivative, it's still going to be equal to 0. So from here you can find that. So you have 4y prime is equal to 2, then your y prime is equal to 1 over 2. So your normal line, you have y equals, so f of x0, which is going to be minus 1 with now the question asks the intersection with this line. So now we have 2 equations. So here we have, so I'm just going to bring it to the other side. So we have y plus 2x equals 1. And then for the other ones, we have 2x minus 3y. Now, if you add these two equations, so you get 4y equals 8, y equals 2, and then you can substitute it to like any of these equations. So I'm just going to use the first one. So you have 2 plus 2x equals 1, 2x equals minus 1, x is. So the point that those two intersect are minus 1 over 2 and 2. No, it's not Newton's method. So you remember when you want to find the equation of the line, so you do y minus y0, or take it to the other side plus, and then you have slope x minus x0. Your slope is usually just your f prime, your initial point, but then here, since you want the normal line, you have 1 minus 1 over m. So that's the only thing you change. X0 is just your initial point. So x1, x2, like doesn't matter, just the start. Yeah, 0, 1, doesn't matter, just one of them. Okay, so for y prime, when you're taking the derivative, so it's based on, wait, let me erase this part. Okay, so you're basically taking d of x of this one, right? So you have x squared. So this one, when you take the derivative, this is going to be dy dx, right? And you can write it as y prime. And then for this one, you have, so the first one is taking the derivative of x squared, which is so 2xy cubed. And then the second way, so you have, when you want to take the derivative of this, the y is kind of like if you have a function. So it's not really the f of x, like you can't get rid of it. So you have 3y squared, y prime times the x squared. And you have y prime, like, you know, implicit differentiation. So you keep that. You can't get rid of your dy dx. Does that make sense? No, it's 7 because you take this to the other side.
Hey, can you show again where you got those two equations? The 4y equals 8 and the 2 plus 2x is 1?
These two equations?
How you turned them into the other equations that are connected by arrows.
Oh, so for these ones, I added the 2. So you add them, you have 4x plus 2x minus 2x equals 8. And then for this one, since I got the y, I just substituted. So I put the y here, so you have 2 plus 2x equals 1. And then I found my x.
Okay, thanks.
Okay, so you know how in product rule, so if you have, gonna use like other variables, so you have like a, b prime, you take, so something like this. That's basically what I did here. So first, this one, you're taking the derivative of y to the power of 3. And remember, so even when you have like x3, right, you take dt of x. You're going to get 3x squared dx dx. And this is equal to 1. But here you have y. So basically, that's why you still have your dy dx. So you still have the y prime. And then the x2 is just multiplying by the other one. Gonna go to question 7. Question 6 was exactly on the notes. We'll post it with the solution. If we have time, I'll go over it. And so for this one, okay, so you can get the common denominator. So you have 1 of x. If you substitute 1, you can see that this is 0 over 0. So you can use L'Hopital's rule. So if you take the derivative of this, so you have 1 over x minus 1. And then for the denominator, you're going to use the product rule. So you have 1 of x and then if you want, I'll go over the other ones because this one's easy. If you just again simplify, you're going to get 0 over 0 again. So it's going to be limit of 1 over x. And then you can use L'Hopital's again. So you're gonna get I think you could get the same answer. I mean, if you get the same, then it's correct. Anyone have questions about this? Okay, so L'Hopital's is right. So if you have 0 divided by 0 and you have limit of, say, f of x divided by, sorry, g of x, you can take the derivative. So this is basically equal to doing f prime of x, g prime of x. But just remember that they're separate. So it's not really like the quotient rule. It's just you take the derivative of numerator, derivative of denominator. And then usually like if for this one, you get like 0 over 0 2 times. So you have to do it again.
Hi. Hello?
Yeah.
Is L'Hopital's rule just for 0 over 0? Or like, can it work with other like indeterminate forms?
I think it was also for infinity over infinity. There was a page in the notes that said when you can use it.
Okay.
I don't want to say the wrong answer, so I'm just gonna say look at that one.
Okay, yeah, because I think I saw it somewhere else with another form, but I wasn't sure. Okay, thanks.
I'm not sure if you can use L'Hopital's for when you get infinity or like 1 over 0.
You can use it for 0 over 0, infinity over infinity, 0 over 0, and 1 over infinity, and then infinity. Sorry, 0 raised to power 0, 1 raised to power infinity, and infinity raised to power 0. You can use it for these forms. L'Hopital.
Okay. Yeah, we'll post the I'll post the clean solutions on PDF. Yeah, you can use the limit. Okay, so for this question, you have well, the square root is just like having power of 1/2, right? So that would make it easier. So here we have 1 plus 2x to the power of x/2. Then by the rules we have, like how to find the derivative when you have power of x, you can change the form of this to e to the power of ln of this. And then, so remember by ln definition, the power goes outside. So you have e to the power of x/2. Then, so by limit log, you know that when you have the limit for the entire thing, you're basically wanting like the limit of the power, right? Because first you want to find that. So you have e to the power. Just gonna put this as an aside here to solve that. So you have limit of x/2 ln of 1. So for this, so you have ln of 1 plus 1/2x. Then x is basically same as saying like 1/x, right? So here you can put 1/x. And this way you're gonna get 0/0. So you can use L'Hopital's rule. And so you have 1/2 limit. The 2x squared here is because so when you take the derivative of the ln, you also take the derivative of what's inside. And the derivative of 1/2x prime is minus 1/2x squared. Now for this one, see, you still get your infinity over infinity. So you can use L'Hopital's again. Yeah, okay, so let me explain this again. So I got the x over 2 because here you have square root, which is the same as saying power of 1 over 2, right? So you have power of x and then multiply it by 1 over 2, right? And then for this part, you write e to the power of ln of what you have, basically same as the saying what, finding what you have, the limit of what you have, right? And then so I separated this because you have x up here, right, in the power. So I separated that. You want the limit of that part. The e part doesn't really matter. So I separated that. Okay. And then so for this one, the reason you want to use L'Hopital's is that, well, your ln is going, when you put infinity, it's going to give you 0, right? And then instead of saying like this is 0 times infinity, I just put it in the denominator to say that's 0 over 0. Right, so that way I can use L'Hopital's rule. And then here, the derivative of 1 over x is negative 1 over x squared. The derivative of ln, derivative of ln is just 1 over what you have multiplied by the derivative of what's inside, right? 1 doesn't matter, so you have derivative of 1 over 2x, which is just 1 over 2x squared. Does this make sense so far? For this part? No, because it's basically 1 over 2 derivative of 1 over x, and derivative of 1 over x is negative 1 over x squared. Why would it be 4? Oh, okay. You don't have to try to write as much as you can. So first find the answer, and then if you have time, go back and explain all your stuff, have the justifications for it.
How did you take out the 1 over 2 on the top line?
Here?
Oh no, the top line with the star.
Oh, this one?
Yeah.
I mean, it's just a constant, so I can take it out by limitless.
Oh, and then you put the x on the bottom like that. Okay.
And then, so now here we got 1 over 4, right? And then you go back to the original one you have. So it's going to be e. We got this from there, that it's 1 over 4. So e to the power of 1 over 4. Oh, so for this part, okay. So for this, okay, wait, let me just go down 2 lines below, right? You have, I mean, the negative signs get canceled together, right? And then you have 1 over 2x. 1 over 2x plus 1 divided by 1 over x squared. And then just change the places so you have, it's the same as saying x squared divided by 2x squared. And then 1 over 2x plus 1, x squared, 2x squared. It's 2x. Then you can cancel out the 2's. X squared. You mean this? I mean, it's simplified. You can just simplify this so you get x over 1 plus 2x. Yeah, you can, but you would still get the same thing because you still have an x here in the denominator, which is going to go to your numerator. Yeah, so the x squared goes to the numerator. So you, okay, if you have a, b, c, d, the way you get this is times q over c, right? So if you have minus 1 over x squared here, your x squared is going to go to the numerator. I had positive because here you have a negative, here you have a negative, they get canceled out. So you get, yeah, it's same as positive. So this next question is kind of like the one before. So you have and you can rewrite this as e to the power of x plus x to the power of 1 over x. And so this power is going to go over here. You have and I'm gonna separate this again so it's easy. And so you have x goes to infinity, 1 over x, 1 of e to the power of x plus x. And here you have infinity over infinity, so you're going to use L'Hopital's rule again. So you have 1 x here, and then derivative of this is 1 over e to the power of x plus x times derivative of this. Okay, forgot that. And the derivative of e to the power of x is just e to the power of x, and then x is just 1. Now, so if you have infinity, this is going to be like infinity over infinity again. So you're going to use L'Hopital's rule again. So limit of x goes to infinity, and then e to the power of x is just e to the power of x. So e to the power of x plus 1. And then again, you have so you have equals 1. So 1 over x is okay. This is same as ln of e to the power of x plus x divided by x. Just extend this line here. It's just 1 times that. Then when you take, like, you use L'Hopital's rule, derivative of x is just 1. And then you can just put the 1 back to your original thing, so you have e to the power of 1. Does this make sense? Yeah, E is the final answer. I don't think so. I'm pretty sure we can just use L'Hopital. So just know where you can use it, and then just say you can use it. We had 15 questions, but question 15 was antiderivatives, which you guys don't have. And then question 6 I skipped because our exam was open book and it was exactly the same question as the notes. I'll go over it if we have time. So like, yeah. Proof. I think we had one delta epsilon proof. No, I'm not sure if yours is open books. Ours. I don't know about yours. Last year's was open book. We had 15 questions, I think. 2 hours, maybe? Or 3, I don't remember. Okay, so for this question, we have x equals to 0, 1 over x squared minus 1 over x. So you can take the x squared out of the square root of 1 plus x, but don't remember to have the absolute value sign minus 1 over x. Now, since we have the absolute value sign, we can like separate it to x goes to like the right hand side and left hand side limits. So the first one is x goes to so this one, since it's already positive, the absolute value doesn't matter. So you have limit of 1 plus x over x minus 1 over x. X 1 plus x minus 1. Since this is 0 over 0, I'm going to use L'Hopital's rule, which is so your denominator is going to be 1, and then you have 1 over 2 squared root of 1 plus x. So you have 1 over 2. Then now you want to get the left-hand limit, so you have your now, so this time your absolute value is going to be negative. So minus x minus 1 over x. So you have limit of x goes to 0, x and this one is just like the actually, okay, so for this one, when you put 0 in it, so you have here, and then this one is going to be minus square root of 1 minus 1. So basically you have minus 2, 0, like that left side of 0. So you know that when you have a negative number divided by 0, that's going to be to positive of infinity, not negative infinity. So this way you see that your left and right limit aren't equal. So the limit does not exist. Does anyone have questions about this?
Miss, I have a question. Does answer is 1 over does not exist?
Yeah, the limit doesn't exist.
Then we can just simplify by conjugate, isn't it? The solving by conjugate is it okay?
Yeah, what do you mean by conjugate?
Like times root x, I mean root 1 plus x over x squared minus 1 over x and plus 1 over x to
Yeah, you can solve it that way too. You would get the same answer.
yeah, I
but
still got does not exist. So I was looking for the answer and it still does not exist. So I figure out it's still working.
yeah, that's correct too. This way it's just easier because you can just bring the x squared out, so you don't have any powers of 2. But you can do it the other way too. It doesn't matter.
Oh, okay, thank you.
I have a question regarding the positive limit.
Yeah.
Hello?
Yeah, I can hear you.
Okay. You know how on the positive limit you got the L'Hopital's rule, and then after that you have the next line saying 1 over 2. Yeah, 1 over 2 square root of 1 plus x. Yeah, this part. How do you get to there from the L'Hopital's rule? Or yeah.
So derivative of x is just 1. Derivative of, and then you want to take the derivative of the numerator. This
Right.
first will be 0, and then the derivative of any square root is basically, so if you have squared up like a triangle or something, it's going to be the derivative of the triangle divided by 2 square root of this, right?
Yes.
And derivative of 1 plus x is just 1.
Oh, okay. I got it. Okay, thank you.
No problem. No, the reason that we did like left and right hand limit here was that you have an absolute value here. So that would just make it easier to just well, you have to separate them because other than that, you can't get rid of the absolute value. And then you see that by doing that, you got the different answer, so it doesn't exist. No, you don't have to prove. I mean, these computation questions. Oh, then if you had marks, I would ask someone because we didn't have to prove that. Okay, so for this question, you have f of x equals ln of square root of e to the power of 6x. Just put this. Okay. And then here you can, so you know that this is basically same as 6x sine of 4x to the power of 1 over 2. So you can bring the power outside. So you have 1 over 2 ln of e to the power of 6x sine of 4x. Now you can take the derivative. And this would make it easier since you don't actually have the squares. So you have 1 over 2 ln of e to the power of 6x sine of 4x. So derivative of whatever you have in the ln is 1 over whatever is inside. So e to the power of 6x sine of 4x multiplied by derivative of this. So this is a product of 2. So first you have derivative of this times sine of 4x plus derivative of sine of 4x times 2. So you have derivative of e to the power of 6x is 6 e to the power of x times sine of 4x. Derivative of sine of 4x is 4 cosine of 4x. Now see you have the 2 here. So this is 2 times 3. 2 times 2, you can simplify this and get rid of the 1 over 2. You have e to the power of 6x sine of 4x. And you have here 3 sine of 4x plus 2 cosine of 4x. I factored out the e to the power of 6x from both of these. And then so you have this is equal to, so you can get rid of the e to the power of 6x. So you have 3 sine of 4x sine of 4x So you have 3 plus 2, and then you know cosine divided by sine is cotangent. So I have cotangent of 4x.
Do we have to simplify every time? The answer?
For like, I
Or
don't
it's okay to leave it the answer just like this?
I don't think you have to simplify, but if you can, it's better.
Oh, okay. Thank you.
I mean, you can do that, but you'll still get the same answer because it's two things multiplied by each other. So you would still have to, like, you would still get the same answer if you separate them. I would like go through all the questions and then like, and then try to like leave the simplification or maybe like some of the justification at the end, or if you have time, if you think you won't have enough time for all the questions, and then go back and complete them. I think the x between I don't think it's relevant here. I think that's just to say that for the square root, you don't have a negative, and you're on. Can I go over the next question because it's not that hard? So this one says that you want to use MBT for it. So remember that MBT says that f of x is continuous on your interval 1/4, and it's differentiable on the open interval, so 1 to 4. And then you know that, so you have, there's a point in that interval that the derivative is, so f of 4 minus f of 1 divided by 4 minus 1. And so you have that your f of x is square root of x. So if you put 4, you have square root of 4 minus square root of 1 divided by 3. And then so this is 2. So you have 2 minus 1. So 1/3. And so this is equal to the derivative of some points. And then you have, so you have, you want to take the derivative, and then so you have 1/2 square root of x, and this is equal to 1/3 plus from here. So 2 square root of x is equal to 3. Square root of x is equal to 3 over 2. And then you can just square this. So you have x equals 9 over 4. So if that's so, for what value of x this satisfies, like, so you have from 9 to 4. Sorry, 9 over 4.
Does respect means like the function is continuous on closed interval and differentiable on the open interval? Is that the meaning of respect?
Well, with respect means that based on like that interval, it doesn't, that MVT is what states that it's continuous on that undifferentiable.
Okay, thank you.
I'd just like to ask, would you have to list down multiple answers if there is if like say depending on the function itself, there may or may not be multiple answers?
If, I mean, yeah, you would have to state it because like consider if this wasn't square root of x, so you have like x squared equals 4, then you would have 2 answers. So you're going to say that, so it says what value of x, so you say 2 values, square root of 2, sorry, minus 2 and 2 satisfy.
Question 13 is a little bit blurry and kind of hard to see. Could you like horizontally like stretch it out a little bit? Because it's hard to see like the x to what power it is. Stretch it out. So not in, out.
Okay, let me just write down the question. Okay, so for this question, when it's saying it wants the function to be decreasing and concave up. So decreasing is when your first derivative is smaller than 0, and concave up is when your second derivative is greater than 0. So for this question, the only thing first you find f prime of x, which is 3x squared over 6 minus 2. And then so first you want to find the intervals which make this negative. So first you want to find the root. So you have equals to 0, then Now you can put like a number that's between them. So if you put, for example, 0, 3, and then -3, you'll see that these two are positive. This one is negative. And then so this is, so you, since you want smaller than 0, this is the interval you want. So for decreasing, you have from -2 to 2. And then now you want to take the second derivative. So here you found that the first derivative is x squared over 2 minus 2. Take the derivative of that, you have 2x over 2, which is just x. So this is just x greater than 0. And then since you want you want both of these to be satisfied, so you want this and this, you're going to take the intersection of them. So your x is going to be from 0 to 2. So the open interval is from 0 to 2.
And why is it 0 to 2? Where the 2 came from?
We got the -2 to 2 from decreasing part. And then this part is for the concave up part. And then you take the intersection of those, so you have. So one of them is here and the other one is here. So your intersection is going to be this part.
Oh, thank you.
Does anyone have questions? The question asked this. So the question says that on which of the intervals is the function decreasing and concave up? So you're looking for the parts that you have. So your first derivative is negative, second is positive.
But since the function is polynomial, isn't this concave up on the 0 to infinity?
No, because it's a power of 3, so it's an odd number. So it's x3 cubed like has this. Only the even numbers have of this form and this form.
But how we know that the concave up is restricted to 0 to 2?
Okay, so for concave up, you know that your function is concave up when your second derivative is positive, right? So here we found first derivative, and so we found the second derivative, and then found the intervals that make that positive.
But like second derivative function of 2 is positive either, isn't it? Oh, okay, it's restricted to -2 to 2, never mind.
So for this question, it's saying that you have a rectangle that it's inside your semicircle. So the way, so here for the sides of my rectangle, this is visible. So here I put X as this side, and then I put Y as this part. You can put it like another way, it doesn't matter, but I just didn't want to have like a divided by 2. Okay, so from this triangle here, this, you have that x squared plus y squared is equal to 10 squared equals 100. And then you can say y squared is equal to 100 minus x squared. So y is equal to square root of 100 minus x squared. I didn't put plus or equals because, well, it's just a rectangle, so you only want the positive, right? Okay. So the question asks, what is the maximum possible of the area of your rectangle, right? So your area is 2yx with my naming, so yours could be different, so it could just be xy. And then you can, here you set that y is equal to square root of 100 minus x squared, so you can substitute that. So you have 2x square root of 100 minus x squared. Now remember that when we look for a maximum point, which is like critical points of your graph, you want to take the first derivative and then check with your second derivative test, right? So it's the points where your derivative doesn't exist or is 0. So here, take the derivative of this. And again. So for here, you're going to use the product rule. So derivative of first one multiplied by the rest. So 100 minus x squared plus x times derivative of this, which is minus 2h over 2 square root of 100 minus x squared. So first you can simplify this. So you have 2 square root of 100 minus x squared plus, so 2's here cancel. So you have minus x squared over square root of 100 minus x squared. So here you can get the common denominator. So you have 100 minus x squared minus x squared, which is equal to 200 minus 4x squared divided by square root of 100 minus x squared. So since we want the maximum, we want the point that this is equal to 0, right? And this is 0 when your numerator is 0. So 200 minus 4x squared equals 0. X squared is equal to 50. X is square root of 50. Again, I didn't put plus or minus because we don't want the negative x is positive. Okay, now we want to check that this point is actually the maximum. So the way to kind of visualize this, so if you have something like, say, this, which you have, wait, sorry, it's the other way. Okay. So at this point, your derivative is 0, and you want your function to be concave down. So you want by second derivative check, you want to check that the second derivative is negative. Then you can say that it's the local maximum up there. Okay, now, so this was our first derivative, so now we can find the second derivative. And we do this by the quotient rule here. So here you have 100 minus x squared. And then so you have the derivative of your numerator, which is minus 8x times the denominator. So 100 minus x squared minus your numerator times the derivative of your denominator. So minus 2x, 2 square root of 100 minus x. And then, so you don't actually have to simplify, you can just substitute your x equals square root of 50. So here you have 100 minus 50, and then it's going to make this part 0, right? So you have minus 8 square root of 50 times 100 minus 50. And then you can see that this is a negative number, so you can check that this x equals square root of 50 is your, like, yeah, it's your largest x, right? And so the question asks your largest area. So here you have x, and then by just substituting in this equation, you can find that your okay, so you have y is equal to here square root of 100 minus x squared. So again, 100 minus 50 is equal to square root of 50. And then so your area, remember that you had here, it's 2yx. So you have 2yx, which is going to be 2. Oh, sorry, 100. Yeah, so your largest area is 100.
Miss, is it just okay to sub the number that 0 to 100 to figure out which is the biggest number to find the maximum area thing?
By subbing in, you just get that it's 100. You don't actually know that that's the maximum. So you have to use the second derivative test to see that the point you found is actually the maximum.
But on the sample final exam, like there's a similar question to this. And then to figure out the maximum, and then they solve the number of the critical point and the end point of interval, which is 0 to 2 for that question.
Okay, so the thing is, so the function you have is this one, right? So it's not exactly a polynomial that you know, you can say like, okay, I know this is like this, so this is going to give me the maximum, so I can just compare from endpoints.
But like this has a same function for this question. It's also a function for the seminal semicircle. And then it does the different way to find the next one, which is a shorter way than this. So I just want to check that is there other way to do faster to find the maximum or something?
I'm not sure if you can check another way without doing the second derivative. I mean, I would check with the instructors, I'm not sure.
Okay.
Actually, there is technically one way that's like checking if it's increasing then decreasing, but I don't know how reliable it is for this type of question though.
Yeah, I'm not sure because the function isn't actually something you know the shape of, because like it's like an x times square root of something. So I think you can just take the second derivative just to check.
Can you also not take just do the first derivative test in this case?
You mean for finding if it's, I mean, okay, so the thing is if it's, the first derivative test says that if it's increasing or not, right? So assume like this is the point that we have the derivative is 0. How would like it being increasing show that?
So I
Wait.
think, isn't it like if it's increasing before x equals to square root of 50, like on to the left, and then it's decreasing to the right, then it's a maximum.
Oh, I see what you mean. Okay, yeah, you can use that one.
All right, thank you.
If we use trig to solve this, how many marks would we get? If we just said to maximize area, the angle has to be 45 degrees, that makes the sides 5 root 2, 5 root 2, and just multiply it like that.
I'm not sure. I think you would get like most of the marks, but I don't know. If you don't have time to do it, you can do it like the way you said, but this was the last question. If you have any questions, let me know.
Can you check the final exam, sample final exam for 2019, page 9, to find the better way to find the easier way to find the maximum?
I don't have access to those. Can you send it like in the chat? Then I can take a look at it.
Okay, wait for a sec.
The seminar is over. I went over all the questions. The question 15 is an antiderivative question. And then this question 6 is just in your notes. I wrote the clean solution. If you want, let me show you question 15. This was our question 15, but you guys don't have antiderivatives. The seminar is technically over, so if you have like other questions, you can ask or I can help you. Yeah, I'll post the solutions with the recording. I'll just wait for Zoom to finish like this converting thing, and then well, for question 6, so sure. Okay. So for question 6, it asks you to prove that it's continuous, and then you want to use that delta epsilon. We didn't have bonus question, but I'm not sure if you will or not. Then question 6, so the way you do for continuous, just So first you want to like pick a delta. So you can pick that your delta is then you're equal to a divided by 2. And then you can prove that the limit exists on that point. That way that shows that it's continuous. Yeah, go over question 3. Yeah, I'm gonna upload this with the recording on the original post that says that there's going to be a seminar. I'll post these two there. Question 3. Which part do you want me to go over? Okay, let me explain question 3 because someone else asked for it, and then I'll show you question 15. Okay, so here this. Okay, so the question here, remember that from here, 1, we found that the f inverse derivative is equal to 1 over f prime of f inverse x. So here you want to find your f derivative and then put the inverse in it, so this. And then here you found that your alpha is equal to 1. That means your f inverse of 6 is equal to 1. So that's why I put 1 here. And then I just substituted this, so it says in the derivative function. Does that make sense? Yeah, the seminar is over. I'm just going over any questions you have.
Can I share my screen? I have a question for the last question.
Yeah, let me stop sharing.
Okay, thank you.
There is a page that was the seminar announcement. It's an instruction note. I'll post it there. Or we can just make a new post. It doesn't matter. We'll do whatever.
So for this one, on this part,
can you zoom in on the question itself?
okay.
Okay. Yeah. Okay, yeah, that was the exact same questions as ours.
I mean, like the functions are similar, so I just figure out that should be same as the last question. And then that's how somebody do. I don't know who wrote this answer, but like they found the maximum like this.
Oh, you can use that too.
Like
Doesn't-
just solving the largest number and smallest number for the domain.
Right. Okay, that makes sense. Yeah, you can use that too, I guess. Both of them should work.
But like for this one, like I tried that way, but like it both are 0, isn't this?
Yeah, so you would get 0, 0. So your square root of 50 would, wait, your domain? Yeah, 0, 100.
I just didn't really wrote the domain. It should be like,
But the thing is your max number for x is 10. Because your r is 10.
oh, is it?
Yeah, because your R goes from 0 to 10, right?
True. I mean, I just wrote the domain per function. Like, oh yeah, it is. It's 10. It's square. Sorry about that.
And not 100, but then, yeah, your method should work. So you find area at 10 and 0 both work, sure.
Oh, it's still 0 though.
Yeah, I think so.
So it's not. It's
Yeah,
so it's different
weird.
from the previous question. So right. So I don't know how to. Is it still working for the maximum?
Yeah, it still works because so both of them, you still see that your square root of 50 would just give you this is still bigger than the other parts.
Like the maximum or minimum happens like this, isn't it? But still the positive value.
Yeah, I guess. Okay, wait, let me just look at it 1 second. Can you go back to the solutions like for the other one?
From the sample.
Yeah. Yeah, so this one they find like both of the
Oh, it's a typo, I
endpoints.
think. It should be 0 somehow.
Yeah, it's 0, but like you find the endpoints, and since it's smaller than the other parts, then that part's gonna be your max. So it's gonna be your global max.
Oh, okay, never mind. Thank you.